All right, so today I'm going to be talking about basically some of the AWS architecture, EKS architecture, right? Design. So basically, we have a different ways that you can, AWS goes about the architectural design. It's kind of very interesting. But one thing I realized today is that when you have your EKS control plane, right? You can also have your how do I say this? You can also have um, your node group. Now you can have like the nodes. I really like. I'm going to say for teams, I will expect them to use the EKS manage, right, node, right. The reason why I recommend EKS manage node is because EKS takes over care of like provides build AMI of images for you, so you don't have to go ahead and build. Now the process of the updating of, let's say you want to move from one node version to the other, right? Because for example, there's a vulnerability in your previous version, your current version in production rather, and you want to update to the new one, right? So it's a good idea to use the AWS manage version, right? Now, for me though, I really see it as a big advantage because the AMI that you're going to use already readily available. Your team doesn't need to spend all your time trying to patch some kind of like AMI, right? Right. All you have to do from your end is just the rollout, right? Because AWS expects you to do the rollout yourself, right? If you want to like roll out, AWS expects you to do the rollout yourself. Um, I mean, that's from my perspective is the biggest uh, advantage. Now, one thing about the node group also that based on architecture is taking advantage of the sports, right? Yeah, instances. Now, by default, of course, we have the on-demand instances that actually charge you by the normal hour, but we also have the spot instances where that come up and go down, right? So you can take advantage of those in your architecture, right? Now, one thing you have to understand is AWS is getting smarter with the spot instances, right? Being able to like detect when instance is about to be rolled out and things like that. So what they advise you is that on your spot instances, try to run stateless workload, and also, right, when you're running your spot instances, try to in your node group, try to have multiple instance type. For example, we AWS has normal C5, C5A, you know you know inst- different version that are within the same group, right? Blah blah blah. So try to make sure your manage node group actually have multiple instance type, so that if, for example, this type C5 is about to get like replaced, or is about to get killed, right? AWS is going to find other types to replace with, right? And I think AWS also has um, well, they also have the concept of balanced node group. So if you have in your EKS, if you have multiple node group, which is recommended, right? Especially if you're trying to use instances, so I have this kind of multiple of this node group. So if you have like multiple node group, it's you can take advantage of a feature that says like balanced, right, node group. So balanced node group, what it tries to do is like it tries to balance the number of instances across your node group. I mean, I think from architecture perspective in this point, right? Um, it's just for reliability, of course, of your node group. Just for reliability of your node group, and also, if I recall correctly, there's a way to like exempt certain node group from the balancing. So let's say you have your node group, is CPU based. This one is GPU node group. This one is GPU. This one is GPU, right? So you don't want this group to be all balanced, to be functioning with the cluster or the scalar like balanced node group. So you don't really want that. So you can just exempt this guy from that, right? So I think all you have to do is just add some custom label to this. Yeah, that's what you have to do from this point. So I think it's a very, very good AWS architecture. It's from architecture perspective, it's a very good thing to take advantage of, right? Let AWS manage some of these things for you so that you don't have to do the all the work by yourself. And also one good thing that AWS does is that it's also, especially with replacing your node, it has a lot of like things in place that they can use to like replace your node. That's a lot of things in place. Some of the things that it has in place is that, for example, let's say you need to replace one of your node, it's going to start by, it's going to like, of course, it's going to like, cordon, right? The node for those in Kubernetes simply means that, right? The service is not going to be sending requests to that particular node. Things are not going to get scheduled on that node. Then you start draining the node, right? You start draining the node, right? It starts draining. Then once it's done draining, you start the replacement, the process, right? Replacement process, right? So yeah, so that is a very, very good way of architecting your application. I think there's a new feature from that was released in Kubernetes 1.21, right? That allows the kubelet to be more to be able to like more responsive like journey. So kubelet itself, it's a feature that I think that was enabled in 2.1, whereby it allows what we call draining. Because before, whenever the kubelet is not aware of the node shutdown. So if your node is dying, the kubelet doesn't know that your node is dying. But in the new version, right, they are taking advantage of something called inhibitor lock, right? Right, inhibitor lock. With inhibitor lock, when your kubelet comes up, it grabs one of those lock, right? It's a feature in Linux. It grabs one of those lock, and so whenever it's about to be shut down, whenever the node is about to be shut down, right, it gets notified, and also it uses this inhibitor lock to tell the node to wait a minute, right, before getting shut down, giving time for all this process to take place, right? So you can see how this plays into sport instances, right? But this is not a guarantee that sport instance is going to be reliable, right? So try to design sport instance for, I would say, try to design your sport instances for like I'm going to say for more stateless application, right? Applications that are just like stateless, right? Applications, your workload, for example, machine learning applications that are like stateless, processing applications, things like that. But that if one of the node goes down, right, you're not going to have much of an issue. So for those that are stateful, things like that, always start to use the on-demand, right, right, instances. And nothing stops you from like having on-demand plus sports. Actually, nothing stops you from having like on-demand plus sports in your architectural design. So that's all I'm going to say for those who are into architecture and things like that. This is where you can design your production system on EKS to be able to take advantage of ability to really use AWS EKS for things. All right, I think I'm going to stop here today, and yeah, that is going to be my discussion for today. I will see you next time.